Okay, so now we are ready to take a look at a situation where we have two voltage sources and we have different resistors, and we're going to try to figure out what's going on here. So we actually have two loops that we're going to be looking at here. We have the top loop here. We know that in the red, what I've marked red here in this section right here, that is all going to have the same current, right? This is all in series here. We know, how about down here? This all, just in this section here, has the same current. And then in the middle, this all has the same current. And so there's actually three separate currents in this one, right? And we're going to need to deal with that. And so we're going to assign direction of the currents. We don't know at this point which, what direction it should be. We're just going to assign them. So we'll say the top one, the current's coming around like this. We're saying the middle, the current's coming around like this, and then the bottom, the current's going like this. Now, the only requirement with this is that it makes sense based on the loop rules. And so, in other words, here, current 1 is coming in, current 2 is coming in, and then they combine together to make current 3. And that's what we're saying here, is that current 1 and current 2 are combining together to make current 3. Now, there could have been, any other different combinations that you could have, and that's fine. As long as you set it up and you say, okay, this is what I think is happening, you'll be fine. Because in the end, if the signs work out, then we know we got the current direction correct. If they didn't work out, then, we'll get a negative and we'll say, okay, the current in that particular part is going the opposite direction. So we're going to go ahead and assign loops directions, and I went ahead and on the top one made the loop come around counterclockwise, and then the bottom one loop go clockwise. It's up to you, what you want to do there. But if you notice here, we have three unknowns, right? We don't know the current in the top, middle, or the bottom. And so if we have three unknowns, we know we're going to need three equations, and that's where the substitution and making these equations is going to be important. So we're going to complete the top loop, and we're going to stop at the start of the top right corner. The first thing that we encounter is that voltage source. So we're starting in the top right loop, and we encounter that first voltage source is 6 volts. All the resistors are 2 ohms. And so going from the negative to the positive terminal, we have positive 6. And then when we get to the next one, I1, it's going to be I1 times negative 2, because the current and the loop are in the same direction. And the reason we have to use I1 is because that's the actual current going through this resistor. Next, as we go through here, we have I3, and the loop and the current are in the same direction, so it's going to be I3 times negative 2 as we go through this one. And then as we finish up, it's going to be negative 2I1, because now it's current 1 going through here, and then it closes out. For the bottom loop, we have the first thing that we encounter here is the I3 times this resistor, same direction of the loop as the current, and we've got that negative 2I3, and then we come around negative 2 I2 as we pass through this one, and then we go from the negative terminal to positive terminal with 6 volts. So positive 6 as we do that, and that finishes that loop. Now, we've already talked about this, what's happening at this spot, right? We have I1 and I2 coming together to make I3. And yeah, and that's actually our last equation. That's the Kirchhoff's current law, right? The two currents will add up for the third current altogether. And so these are our three equations. We have our three equations. We have our three unknowns. And we're going to be able to figure out which ones are the current in all three, actually. Three equations for three unknowns. Now, when I made this problem and I made the solution, I made a mistake, and I decided to keep this to show you what could happen if you don't really have a plan, or you think you do and you go through and it doesn't work. And so I'm going to show you that. So what I tried to do here is I said, okay, well, I'm going to substitute I1 and I2 in for I3. And I did that, right? And I placed that in there, I've factored it out, and I've got all that. And so I'm left with, I1s and I2s. And, I substitute, and that's fine. Get it all to I1. Now, I place this, right? I kind of simplify this, 2I2 minus I3. I place that in there. And then I learned my mistake. I place that in there, and I still have two unknowns. I don't know I2, and I don't know I3. And that's a problem, right? So as we substitute, we have to, kind of set it up to where things are going to cancel out, and it'll be helpful. So yeah. So we got to make sure to isolate for what we need. So instead of doing that, I separate or isolated for I1 in here, and then I could substitute this in for here. So when I place I3 minus I2 in for I1, that's what it looks like here. I just substituted in here. And this will be good because now I have I3 and I2. And then once I simplify, that's all I'm left with here, I3s and I2s. So that first substitution, when you bring that in here, you want to be able to get it to where if you once you substitute again, you're going to be able to eliminate those variables and then at least get one out. So we simplify there, factor the -4 in, and we simplify and get it down to what I2 can be. So we've got that, and we can place this into the last equation and substitute. So I just divide it by both sides, and then I could place that over and place that in. And yeah, and so what we end up getting is 1.8 amps for the I3. And because it comes out as a positive, we know that the direction is okay. So it is going to the right inside there, and it is 1.8 amps. When I place this back into here, I can get what the current is, and this is giving me positive 1.2 amps. So that means that I2 is in the correct direction. If this came out as a negative, it just means that the current would be going opposite. And then lastly, I1 is 0.6 amps, and so that's positive. So the current is going it is actually going this way, and that's what it really is doing, and that's all set there.